Welcome to the DLR webcast.
SOFIA stands for Stratospheric Observatory for Infrared Astronomy. It's a joint project of the US space agency NASA and the German Aerospace Center DLR. SOFIA will be used to carry out astronomical observations at high altitude using this aircraft and an integrated infrared telescope. NASA is providing and modifying the plane. DLR was responsible for commissioning the development and construction of an infrared telescope like this one and for integrating it into the aircraft as well. The plane is a Boeing 747 SP Special Performance. It has a shortened fuselage. Pan Am brought it into service in 1977 with the name Clipper Lindbergh. At the start of the program in 1996 and 97, NASA bought the aeroplane and began to make the corresponding modifications so that a 17-ton telescope could be integrated into it. The key modifications are a 4x6 meter opening in the rear part of the fuselage, out of which the telescope will make its observations. And this large opening will be covered with a movable door that can be closed to protect the telescope when the plane is on the ground and only be opened at high altitudes. Another significant modification to this aircraft is that an additional pressure bulkhead has been installed about halfway down the fuselage. It separates the cabin area where the scientists, technicians and engineers will work from the open telescope area. In addition, the pressure bulkhead will also accept and hold the telescope. SOFIA will be used in particular to research the formation of stars and planets, which is expected to be a standard process. These observations will penetrate deep into optically dense intersolar clouds. You can only see the surface, but with infrared radiation, it's possible to look into them, almost like X-ray vision, in order to gain understanding of the details of star formation. That will also pave the way for insights about the formation of our own solar system. The infrared radiation to be observed by SOFIA unfortunately doesn't reach the Earth's surface because it's absorbed and blocked by water vapor in the Earth's atmosphere. That's why ground-based telescopes are unable to cover this interesting area of inquiry. With SOFIA flying above what's known as the tropopause, at altitudes of 12 to 14 kilometers, the telescope will be higher than 99% of this water vapor, so that infrared radiation from space can be observed almost completely unhindered. Of course, it would be even better to make observations from space, where there's no residual atmosphere at all. That would make possible even more sensitive measurements from much further in space. But observatories of this type are very expensive and, as a rule, too financially risky. The SOFIA telescope and observatory can be maintained and repaired if something breaks. The instruments can be exchanged at any time, or improved, or replaced with completely new instruments that feature the very latest in technology. Observatories in space have sensors that are 10 to 15 years old, because only fully developed technology is sent into space. The major German role in SOFIA is the infrared telescope. At the time, DLR commissioned the consortium of MAN Technology and Kaiser Trader to develop it. The telescope was built, shipped to the US and installed in the aircraft. Another significant part is the role Germany plays in operating this observatory in the US. The telescope accounts for about 20% of the total investment in the project. As a result, Germany takes part in 20% of the operation and receives a 20% share of the observation time for German research institutes. The third significant elements are the instruments attached to the telescope and that are used to make the actual observations. Two instruments for this purpose have been developed in Germany by Max Planck Institutes and university-based institutes. One is a spectrometer called GREAT that was developed under leadership from the Max Planck Institute for Radio Astronomy in Bonn. And the second large instrument is an imaging camera known as FIFI-LS from the Max Planck Institute in Garching.
The first light flight is one of the
highlights of this program. After years of ground tests and initial test flights that began in December 2009, when the door was opened for the first time, but the telescope wasn't operating. Now, with the first light flight, the entire system will be tested from start to finish. The door will be opened, the telescope will be ready to go, and an American instrument will be used that will measure the optical properties of the telescope. And at this opportunity, it will also be used to make the initial images of astronomical objects in preparation for the first genuine scientific observations starting at the end of 2010.
Dann erste echte wissenschaftliche Beobachtungen ab Ende 2010. Der erste Einsatz deutscher Instrumente ist für das Jahr 2011.
The first use of German instruments has been scheduled for 2011. At the start of 2011, the German instrument GREAT will make observations for the first time. 3 flights are planned, that in part will be used for the calibration and gauging of these instruments. And 2 or 3 months later, further flights are planned, and it's expected that first class